All right, we're going to try this, and my son Derek has asked me to kind of explain a few things. What I'm doing is I'm designing the beam and the system by which this patio or porch cover is going to be built. And one of the things that he asked me to do is to kind of go over a little bit what exactly has to happen to make sure the size of the materials are correct. And then you could do the foundation correctly. So this is going to be the first of several small videos. First thing that I've done is try to analyze the design. We'll hold this up here and I'll try to take close-ups of it later. But what I'm doing is I'm using a 2x6 joist network at 16 inches on center, and that will support the decking. And the reason I'm using 16 inches on center is that because the veranda decking, which is a composite plastic material, will bend if it's too wide apart. You can actually put it at 24 inches on center, but in our Arizona heat and sun, eventually you'll get little waves in it, so I don't want that. So I'm going to put it at 16. You could go down to 12. The only problem I find with 12 inches on center is it's sometimes hard to nail the blocking in place. So 16 works a lot better. The beams themselves, which are the larger items here, are going to be glue lams. And these glue lams are set at 7 foot on center apart. That's because of some existing piers that were here when we bought the house. So that's a controlling factor. Now after you figure that out, I'll give you the next chart here. It's what you call distribution of load, or what's the area of load influence. Now remember I said that the joists were going to be 14 feet, and that means half of the load on that joist from the decking will go on one beam and the other half will go on the other. Now that's rather simplistic. If you use a computer model, you would find that although they would be equally loaded, the tributary load, or the load imposed by the dead materials, that's the veranda decking and the 2x6s themselves, any blocks, nails, fasteners, etc., will be influencing. So I'm just going to draw half of it. This is my glue lam beam. Because of aesthetic reasons, I want to make it at least 3 1/8 or 3.5 inches wide and 12 inches deep. So that's what my control factors are. Now what I have done is I've calculated what the timber manual and the building code uses for glue lam beams, and I've used the one for snow loads because quite frankly they're more strict than if you used just rain loads. So I'm going to use that one, and I'm going to start out at the 35 pounds per square foot. Now what I have done is, if you go onto the computer, you can pull out table 26 for glue lam beams, and it gives you a span chart and a loading chart based on 35 pounds a square foot, which is quite a bit. And the little highlighted area in yellow here is the one for the 3 1/8 by 12 inches, and then I go all the way out to the end, and it says what the load would be at 24 feet, which happens to be the distance I have to span at the back patio to go both over a hot tub area and over a fountain area. So 24 feet is set. And if you could read this micro thing, which by the way, when you go on the internet and look it up, you can actually blow it up to a size that you can read. Unfortunately, this doesn't go out to the 24 foot, so I'll just have to tell you that. You'll have to believe it. It's 174 pounds per lineal foot. So using that table, and I'll give you another little chart here, that beam will hold 174 pounds per lineal foot, quite a bit. And there is a D behind it, which stands for deflection, which basically means that the dead load weight on the beam, the controlling factor for spanning 24 feet, if you put 174 pounds on it, is it would start to deflect. The building code says deflection can't be any more than 1.5 inches. This is going to barely deflect at all, because as I went through and did my calculations, I only come up with 56 pounds a lineal foot, so I'm roughly a third of it. So the best that thing is going to deflect, if you could even see it, would be maybe a half an inch. Again, I'm going to go over next how I actually figure out the footing sizes, but I've kind of drawn in here, you can see the deflection here. The load would be even all the way across. You have to use it for pounds per lineal foot, and so it would be 7 foot times the dead load of the materials, which are roughly 4 pounds. You divide that into what the overall is, and you can get what the load is going to be on each of the beams. All right, I'm going to see how this worked.